Okay, so in last video we have solved the problem sum of prime digits. Now in this video we are going to learn how to check prime number. Okay, check prime number. Check a number is prime or not. Check prime number or not. Okay, so how we will check? Okay, so we should know the basic thing before understand. First we should know the logic. Okay, so here in this playlist we are learning basic logic to advanced DSA logic. Okay, so we are learning how to handle DSA problem by solving small problem. Then we will move to the advanced problem slowly, right? So how to check whether number is a prime or not? So for example, I am taking a number like 2. So if a number has two factors, means that is what prime number. So factor means 1 and 2. These are two factors. So this number has two factors. Okay, means this number is divisible by 1 and 2, and this number is not divisible by other than these two numbers. For example, let's talk about 3. So 3 is divisible by 1 and 3 is divisible by 3 itself. So it is also has two factors. Is there any other number who can divide 3? No, there is no number who can divide 3 other than 1 and 3. For example, let's talk about 4. So 4 can divisible by 1, 4 is divisible by 2, 4 is divisible by 3. I mean, sorry, I'm writing 3. 4 is divisible by 4. So how many factors are there? 3 factor. If a number has more than 2 factors, means that number is not a prime number. So this is not a prime number. For example, let's talk about 5. So 5 is divisible by 1 and 5 is divisible by itself. So total factors are 2. So this is prime number. Let's talk about 6. So it has 1, it can divisible by 1 and it can divisible by 2, it can divisible by 3 and it can divisible by 6. So how many total factors? 4. So if factors are more than 2, this is not a prime number. So this is the basic logic. This is the basic idea. Okay, we have to write the logic. Okay, so the logic is when factors are 2, when factors are 2, so this is what prime number. Factors means divisible. Okay, 2 is divisible by 1 and 2 is divisible by 2, means two factor, and other than these two numbers it cannot divisible by any number. So let's write the logic. So what we will do, we will create one function. Okay, here I am writing initially pass because I am not writing any logic right now. I will take a number from the user, integer number, input. Okay, I will display one message to the user, enter a number. Okay, user enter a number. For example, user entered a number called 5. Okay, so what I will do, I will send this number inside the function. Okay, and okay, let me write here num. So let me send num, and our function should receive one value. Okay, so it is receiving 1. Okay, we got the number. Now we have to perform the operation. Okay, so what we have to do basically, we will check the factor. Okay, so how we will check? We will check for I in range. Okay, what is the range? Okay, what should be the range? Let me tell you once. Okay, for example, I have a number 5. So we will execute loop from 1, 2, 3, 4 up to 5. Okay, and we will increase the factor count. Okay, we will check the factor count. So 5 is divisible by 1. Yes, 5 is divisible by 1. So increase the fact count. 5 is divisible by 2. No, 5 is not divisible by 2. 5 is divisible by 3. No, 5 is not divisible by 3. 5 is divisible by 4. No, 5 is not divisible by 4. 5 is divisible by 5. Yes, 5 is divisible by 5, means increase the count. So the factor count is 2. So if the factor count is 2, means we will say this is a prime number. Let's take another number, 6. So we will execute the loop 1, 2, 3, 4, 5 and 6 up to this number, and we will check 1 is divisible by 6. Yes. 2 is divisible by 6 is divisible by 2. Yes. Okay, And 6 is divisible by 3? Yes. 6 is divisible by 4? No. 6 is divisible by 5? No. Divisible by 6? Yes. So what is the factor count? 1, 2, 3, and 4. So factor count is 4. If factor count is 4 means we will say this is not a prime number. So each time we will increase the factor count. Let's talk about 7. Okay, so we will execute loop from starting point 1, 2, 3, 4, 5, 6, and 7. Right? So we will say this 7 is divisible by 1. Yes. 7 is divisible by 2. No. 7 is divisible by 3. No. 7 is divisible by 4. No. 7 is divisible by 5. No. 7 is divisible by 6. No. 7 is divisible by 7. Yes. So what is the factor count? 1 and 2. So factor count is 2. So this is also a prime number. So are you understanding? So user entered here number, suppose 7. So we will generate how many range? 1, 2, 3, 4, 5, 6, and 7. So how we will generate? We will write the starting point 1. Okay, and ending point is what? N plus 1. N plus 1, why? Because if your n value is 3, so loop will execute by 1, 2, and 3 it will not execute. Okay, if your n value is 4, so it will execute 1, 2, 3, and 4 it will skip. If your n value is 5, so it will execute 1, 2, 3, 4, 5 it will skip. So that's the reason we want to execute it by 7. So I will write n plus 1. N plus 1 means 8. If you will write here, if you want to execute this loop completely 5 times, so write here 6. So 1, 2, 3, 4, 5. It will execute till 5. Okay, so that's the reason I'm writing that. Okay, so I hope you are getting the idea. So now it should start with 1 and it should execute till n plus 1, right? And each time we will check if this n means our number. This number is modulus by I means what number? Suppose our n value is what? N value is 5. N value is 5 means how many numbers it will generate? 1, 2, 3, 4, up to 5. Okay, so each time we have to check. So 5 is divisible by 1. Yes, 5 is divisible by 1. This is 5 divisible by 1. So what we will do? Divisible by 1 means 0, equals to 0. So I will increase the fact count. Fact. Okay, I will increase the fact plus equals to 1. Okay, let me define factor here. Okay, if factor, okay, so what's the next number is what? 2. So here it will check 2 is divisible by 5 is divisible by 2. No. So 5 is divisible by two numbers only, 1 and last number. So the factor count will be 2 in last. Okay, after that what we will do? We will we will return what? We will return the factor. Okay, we will return f. Okay, where it will go? It will come here. Okay, it will come here. So we will store inside a result. Okay, we are calling from here. So this factor will return here. So result is nothing but factor. Result, or we can simply write factor. Okay, because this f is nothing but factor count. So we will check if factor is equals to 2. If the factor is equals to 2, we will say, okay, what we will say? Okay, what is this number? This number is a prime number. Okay, else what we will say? If factor count is more than 2 means we will say num is not a prime number, right? So let's execute this. So let's enter 7. So 7 is a prime number. Okay, good. Let's talk about 6. 6 is not a prime number. So I hope you are understanding the logic. Logic is very simple. Logic is very simple. If a number has more than two factors, means that number is not a prime number. And if a number have only two factors, then that number is what? A prime number. Means if a number is divisible by 1 and itself only, okay, so that number is a prime number, and we are counting factor and we are returning factor, and it will come here. Okay, returning result will come here. Otherwise we can check here also, we can write these two lines here also, no issue. But this function containing only the logic. Okay, so thank you everyone for watching this video. Just practice this code. If you practice this code, if you implemented this program, just write in comment. Just copy this code and paste in comment so that I can see your active participation. And it will be very nice of you if you will paste the code in comments. Okay. So thank you everyone for watching this video, for giving your valuable time.